by the end of this session, you will be able to find values of trigonometric functions for any angle. Let us begin by considering an angle theta in standard position. So we have the x and y axis, and here we have theta in standard position. And then we'll let the point P be a point on the terminal side of theta. So this is the terminal side of theta, and we have the point P here given by its x and y coordinates. And then we'll let R represent the non-zero distance from P to the origin. This is the P, here is the origin, and in black we have the non-zero distance R. And of course, because here we have a right angle triangle, we can use Pythagoras to find R. That is, R equal the square root of x squared plus y squared, which of course is non-zero. Then, the trigonometric functions of theta are as follows. Sine theta is given by y divided by r. Cos theta is given by x divided by r. Tan theta is given by y divided by x, where x is non-zero. And from these we can find cosec theta, which equals r divided by y with y non-zero. Sec theta, which equals r divided by x with x not equal to 0. And lastly, cot theta, which equals x divided by y with y non-zero. Here's the first example. Let minus 5, 2 be a point on the terminal side of an angle theta in standard position. Find the exact values of the 6 trigonometric functions of theta. So from the point minus 5, 2, x equal minus 5, y equal 2. And of course we can use Pythagoras to find r. That is, r equal x squared plus y squared, which equals square root 29. And therefore we will use x equal minus 5, y equal 2, and r equal root 29. Now sine theta is given by y divided by r, which equals 2 divided by root 29. And we can do the same for cos theta. To get cos theta is minus 5 over root 29. Tan theta equal 2 divided by minus 5. Cosec theta equal root 21 over 2. Sec theta equal root 21 over minus 5. And lastly, cot theta equal minus 5 over 2. Here's a question for you to try. You're given the point 1, 3 as being the point on the terminal side of an angle theta in standard position. And then you need to find the exact values of the 6 trigonometric functions of theta. So you may now pause the video and attempt the question, and when you are ready to continue, please press play. So you should have found x, y, and r to be as follows. And from these, you should have found the values for sine, cos, tan, cosec, sec, and cot to be like so. We will now move on to quadrantal angles. When the terminal side of an angle theta lies on one of the coordinate axes, the angle is called a quadrantal angle. Let's illustrate this with some visual examples. So here, of course, we have the positive x-axis, where the terminal side lies on. And in this case, we see that theta is 0 degrees, or 0 radians. So here we have x equals some distance r, and y equals 0. Similarly, the terminal side of the angle theta can lie on the positive y-axis. So in this case, x is 0, and y equal r. Of course, for this example, theta equal 90 degrees, or pi by 2 radians. We can also have the terminal side lie on the negative x-axis. So now, of course, remember r is a positive quantity. So here x equals minus r and y is 0. And here theta equals 180 degrees, or pi radians. And lastly, theta could also lie on a negative y-axis. So again, x will be 0, y will be minus r. And this is for theta equals 270 degrees, or 3 pi by 2 radians. Now, you can find the values of the trigonometric functions of quadrantal angles by choosing any point on the terminal side. So let's think about this. Well, we have x, y, and of course, we have r, because 1 of x or y will always be 0. If we look at all the examples, 1 of x and y will always be 0. So r is easily given. So for simplicity, if we take r equals 1, then all the problems will reduce to simple equations. Here's an example. Find the exact value of cos 270 degrees. Well, first of all, we note that the terminal side of 270 degrees in standard position lies on the negative y-axis. So this is indeed a quadrantal angle. So if we can see here, because theta is 270 degrees, we have this point here, 0 minus r. So x equals 0 and y equals minus r. Now, of course, we said that we wish to take r equals 1 for simplicity. So for r equals 1, we will have the point 0 minus 1. And this will be the point that will lie on the terminal side of the angle. So it will be this point here. So r in this example will be 1. So 0 minus 1 will be the point. So therefore, x equals 0, y equals minus 1, and r equals 1, because this is what we have taken for simplicity. So cos of 270 degrees will equal x divided by r. Of course, x is 0, r is 1. 0 divided by 1 equals 0. So cos 270 equals 0. Here is an example for you to try. Find the exact value of cosec pi by 2. So you can now pause the video and attempt the question. And when you are ready to continue, please press play. So if you went through the steps, again, for r equals 1, you would have found that cosec pi by 2 equals 1.
Now before we continue, please don't forget to like the video and subscribe to our channel. As a reminder, we offer private and group online math lessons on Zoom. The first session is always free. We cover all UAE National Curricula, American and British curriculums. We also have the best MSAT math test preparation course with a 50% discount for groups. So if you are interested in a free lesson, click the link in the description below, and send us a message now. Okay, with that said, let's get back to our lesson.
So let's have a look at other angles. So when angles are neither acute nor quadrantal, we will consider the 3 cases shown below in which a and b are positive real numbers. And what we'll do is we will compare the values of the sine, cosine, and tangent functions of theta, one angle, and theta dash. So theta with apostrophe is read as theta dash. This is another angle. So of course, if it's not acute, then it can't be in quadrant 1. So we'll start with quadrant 2. So here we have the angle theta on the right in black and theta dash on the left in red. Now, if we take the sine of theta and sine of theta dash, we see that they're both equal, b over r and b over r. If we take the cosine of theta, we get minus a over r. But if we take the cosine of theta dash here, we just get a over r. Remember, a and b and r are all positive quantities. Now, tan of theta equals minus b over a, but tan of theta dash equals b over a. So it's important to note that the quantities are all the same. The only difference in some cases, specifically in the case of cos and tan, we see that the times is negative for theta, and for theta dash is positive. Same for tan. But sine, we see that sine of theta and sine of theta dash are both positive, b divided by r. Moving on to quadrant 3, we have the following expressions. And for quadrant 2, we also have the following. And again, when we look at the quantities here for sine, cos, and tan of theta, and sine, cos, and tan of theta dash, we see that the quantities are the same, apart from the fact that in some instances, we go from negative to positive, or positive to negative. In other instances, it stays the same. So in quadrant 2, we see that sine of theta and sine of theta dash is the same. In quadrant 3, we see that tan of theta and tan of theta dash is the same. And in quadrant 4, we see that cos of theta and cos of theta dash is the same. So in this case, theta dash is called a reference angle, and it can be used to find the trigonometric values of any angle theta. So this angle theta dash is going to be used to find the trigonometric values of some angle theta. So as previously stated, notice that in some cases, the three trigonometric values of theta and theta dash are the same. In other cases, they differ only in sign. So sign here meaning sometimes it's positive, sometimes negative. Let's make this more formal by talking about reference angle rules. So if theta is an angle in standard position, its reference angle, theta dash, is the acute angle formed by the terminal side of theta and the x-axis. So what does this mean? Well, the reference angle theta dash for any angle theta, where theta is between 0 and 360 degrees, or of course 0 and 2 pi radians, is defined as follows. So in quadrant 1, we see that theta is of course acute. So therefore the theta dash equals to theta, because the definition says that theta dash is the acute angle formed by the terminal side of theta and the x-axis. So this is the terminal side of theta, and here is the x-axis, and this is the acute angle, okay? Because this angle here would not be acute, it would be obtuse. So in quadrant 1, theta dash is the same as theta. But in quadrant 2, we can see that the acute angle now is this angle here on the left. So theta dash is now the angle on the left. And how would we find theta dash? Well, if we know theta, if we did 180 degrees, which is a semicircle, minus the value of theta, we will get theta dash. So theta dash equals 180 degrees minus theta, or pi minus theta in radians. In quadrant 3, we see that to find theta dash, we'll have to do theta minus 180 degrees, or theta minus pi. And in quadrant 4, if we did 360 degrees minus theta, we'll get theta dash. So 360 degrees being the full circle, minus theta will give us the angle here, theta dash. Again, we can see that in all the examples, specifically in quadrant 4, quadrant 3, quadrant 2, and quadrant 1, theta dash is acute, meaning it's between 0 and 90 degrees. So these are the reference angle rules. So to find a reference angle for angles outside the interval, where theta is between 0 and 360 degrees, or of course between 0 and 2 pi radians, what we need to do is we need to first find the corresponding coterminal angle in this interval, and then consider the reference angle rules. So now we'll move on to a few examples. In example 3, we need to find the reference angle of 220 degrees. So here, theta is 220 degrees, and we must find theta dash. Well, we know that the terminal side of 220 degrees lies in quadrant 3. So let's look at the visual here. Okay, 220 degrees will be in quadrant 3. So if we want to find the reference angle, theta dash, we must do theta minus 180. So theta is 220. So the reference angle, theta dash, is given by 220 degrees minus 180 degrees, which is 40 degrees. So it's an acute angle where the reference angle is 40 degrees. Here's the third task for you to complete. You are asked to find the reference angle of 3 pi by 5 radians. You can now pause the video and have a go at the question, and when you are ready to continue, please press play. Right. So if you follow the same steps, you should have found that the reference angle theta dash equals 2 pi divided by 5. So now we can come up with a general rule for evaluating trigonometric functions of any angle. Step 1. given the angle theta, find the reference angle theta dash. Again, just to illustrate this point further, here is a graph, and here we have theta and theta dash. Step 2, we find the value of the trigonometric function for theta dash. That is cosine of theta dash, tangent of theta dash. This is what we mean by the value of the trigonometric function for theta dash. And step 3, using the quadrant in which the terminal side of theta lies, determine the sine of the trigonometric function value of theta. Now let's explore this further. What does this mean? Well, we can consider the sine of the trigonometric functions in each quadrant. That means depending on what quadrant the function is in, or rather theta is in, the sign of various trigonometric functions changes. The sign meaning whether it's positive or negative. So in quadrant 1, when theta is between 0 and 90 degrees, all sine, cosine, and tangent functions are positive. Whereas in quadrant 2, when theta is between 90 and 180 degrees, only sine is positive. In quadrant 3, where theta is between 180 and 270 degrees, only the tangent is positive, and the sine and the cosine are negative. Whereas in quadrant 4, we see that cosine is positive, and the sine and tangent functions are negative. And of course, quadrant 4 is when theta is between 270 degrees and 360 degrees. So when we do the example, you will see how we can use this diagram to find trigonometric function values. Similarly, it's good to know the exact values of some trigonometric functions. That is, for the following angles: 30 degrees, 45 degrees, and 60 degrees, or the equivalent angle in radian measure. Now, for example, if we consider 30 degrees, we see that sine of 30 is 1/2. Or 45 degrees, tan of 45 is 1. Now, memorizing these values will help us to calculate trigonometric function values very quickly. So we will use these two diagrams on the left and the table here in the next example. So let's come to example 4. Find the exact value of tan 315 degrees. So theta is 315 degrees. And we know that the terminal side of 315 degrees lies in quadrant 4. So if we look at quadrant 4, of course we're evaluating the tangent of 315 degrees, so tan. We see that tan is negative. So we know that tan of 315 degrees will be a negative number. So then if we look at the reference angle, well, using the reference angle rules, we know that theta dash is 360 minus 315, which is 45 degrees. So what does that mean? We know that the reference angle, 45 degrees, is going to be used to find the value of tan of 315 degrees. And we also know that because 315 degrees is in quadrant 4, the tangent function will be negative. So that means that tan of 315 degrees equals minus tan of 45. The minus because in the fourth quadrant, tan is negative, and 45 degrees because this is the reference angle. And of course, if we use the table here from the previous slide, if we look at 45 degrees, we see that tan of 45 degrees equals 1. So that means tan of 315 degrees equals minus 1. You can now have a go at a question yourself. Find the exact value of sine 3 pi by 4. You can pause the video and answer the question, and when you are ready to continue, please press play. If you follow the steps, your answer should be as follows. Sine of 3 pi by 4 equal 1 divided by root 2.